Hey everybody, Math by the Moon back with another video. Today I'm going to talk to you a little bit about some of the more difficult radical simplifying problems. They're not necessarily more difficult, just they look different. So the first couple involve multiplication. And the first thing you could do is you could choose to take these and multiply them together to make them a single radical and then treat it like normal. So if that's the case, this would be 96 and x to the 11th. And then however you want to simplify 96, maybe you're a factor tree person, so you use 12 with 8. And then we do our pairs thing, right? So for every pair, we take out a square. And then these guys go back in. I'm going to leave some room like I normally do. 2 times 3 is 6. As far as these, I would still take and divide by 2, so I'd have x to the 5th, and that would be 1x left in. So our final answer for this problem, 4x to the 5th, square root 6x. Now, if you don't want to push these together to make a single radical, you could just give them independent factor trees, but then consider all the factors to be under one radical. So like whatever the square root, whatever 72 times 6 is, and then you break it down into 6 and 72 anyway. So 3 and 2, 8 and 9, so you do have to watch out. This is a cube root, so we're looking for sets of 3, so that would make a 2 on the outside. 1, 2, 3 makes a 3 on the outside. And this guy, this single 2, goes back inside the cube root. And now I probably think about these two things together more like a cube root of x to the 9th, because when you're multiplying, you add their exponents. So we'll divide this by 3, and we get x cubed. So our final answer would be 6x cubed times the cube root of 2. So again, you can either push it both together and simplify it one time, or you can kind of do it independently but treat it as all of these factors are under one radical. So you can pull triples from or pairs from either of these two factor trees to make pairs outside or triples outside. The next questions, first one there is a square root with a fraction. So with a fraction, you can, again, treat this as two separate problems, 24x to the 5th over square root 25. Well, that's easy, right? Square root of 25 is 5, so I already know that part of my answer. And then I only have this one left to do. If it's simplified here in any way, you could do that inside the radical, like divide or reduce. 24x to the 5th, however, I'll probably take that with a 4 and a 6 and do it the perfect square method. So this will be a 2 on the outside, root 6 on the inside, and 5 divided by 2 would be 4, and 1 left in. Whoops, 5 divided by 2 is 2. My bad. And if these would reduce at all, this 2 and this 5, if they would reduce at all, you could definitely reduce that down. For us in this case, that's as low as it's going to go. This next one presents an issue because it's now a fourth root. So we'll give the 48 a factor tree, but instead of looking for groups of 3 or groups of 2, we're looking for groups of 4. So this group of 4 right here would make a single 2 on the outside, and this guy goes back in. Okay, so then we do the same thing with these exponents as we've done in the past. We're going to group them into groups of 4, which is really divide by 4, right? So 16 divided by 4 is x to the 4th, nothing left in. 22 divided by 4 is 5, so that only gets us 20 of them. So 20, that leaves us with 2 left. And 4 can't go into 3 at all to make a group, so that z cubed goes back in. So if you happen to see, any of these types of questions, looking a little bit different. Hopefully this little quick video will help you do those. Let me know if you need anything.